Most front-end systems are fragile. One failed request, one unstable render, one layout shift, and suddenly the entire interface starts breaking apart in front of the user. Buttons jump across the screen, animations stutter, state becomes inconsistent, the experience collapses. Modern frontends are still built like static machines reacting to damage after it already happened. But what if the interface could predict instability before users ever saw it? What if components could observe themselves, analyze their own behavior, and autonomously correct failure in real time? Today we are building a self-healing front-end system using predictive state logic and real-time telemetry, not reactive UI, adaptive UI. Most front-end engineering today is fundamentally reactive. We wait for something to fail, then we respond. We re-render components, retry network requests, patch edge cases, and display fallback states. The entire architecture revolves around damage control, and the deeper systems become, the more fragile they become, because modern interfaces are dealing with massive complexity. Real-time state synchronization, streaming APIs, responsive layouts, animation systems, hydration pipelines, and cross-device rendering. Every layer introduces instability, and most systems have no awareness of their own condition. The component does not know when it is becoming unstable. It simply crashes into failure. That is the problem. We are building interfaces that can render but cannot adapt. The first step toward autonomous front-end behavior is observation. Before a system can self-correct, it needs awareness. We start by injecting telemetry directly into the component lifecycle, not analytics, behavioral telemetry. The component continuously monitors itself in real time. Render duration, layout instability, frame timing, interaction latency, state transition frequency, viewport shifts, and network response behavior. Every interaction becomes data. Using mutation observers, performance observers, render timing metrics, and state snapshots, the interface begins building a live behavioral profile of itself. Now something important starts happening. The UI is no longer passive. It becomes observational. The component begins understanding the conditions surrounding its own stability, and that changes everything. Observation alone is not enough. Now the system needs prediction. This is where predictive state logic enters the architecture. Instead of waiting for failure, the component begins estimating future instability before it happens. Think about a layout shift. Normally, the browser reacts after the content moves, but predictive state systems can detect signals leading up to instability. Incoming content dimensions exceed expected constraints. Network timing indicates delayed hydration. Interaction velocity spikes beyond normal thresholds. The system begins recognizing patterns, and once patterns become predictable, the component can intervene early. Before the layout jumps, the container stabilizes itself. Before latency becomes visible, the system preloads fallback states. Before animation performance drops, the component dynamically reduces complexity. This is no longer static rendering. This is adaptive rendering. The interface is reshaping itself around probability, and the goal is not perfection. The goal is resilience. At the center of the system sits a lightweight inference engine. This is not some massive artificial intelligence model. Most of the power here comes from systems engineering. The inference layer evaluates behavioral signals and determines corrective actions. If render timing exceeds thresholds, the component enters stabilization mode. If network latency increases, the system swaps interaction strategies. If viewport instability rises, the interface locks structural dimensions temporarily. The component continuously cycles through observe, predict, and correct. Observe, predict, and correct. This creates a feedback loop of autonomous adaptation. Over time, the front-end starts behaving less like a static application and more like a living system responding to environmental stress. This is where the architecture becomes truly powerful. The self-healing loop. The system detects instability, predicts the probable outcome, then applies corrective behavior before catastrophic failure occurs. Imagine a large dashboard application. Network conditions suddenly degrade. Normally, the UI would freeze. Components would shift, loading states would flicker, and interactions would fail. But the predictive system sees the degradation early, so the interface begins adapting immediately. Animations scale down, rendering priority changes. Fallback states preload invisibly. Interaction density decreases. The user barely notices anything happened. That is the difference between reactive engineering and resilient engineering. The system absorbs instability instead of collapsing under it. Suddenly, the front end stops feeling fragile. It starts feeling alive. This idea extends far beyond a single component because front-end systems are evolving. For years, we optimized primarily for rendering speed, but the next evolution may be adaptability itself. Interfaces that anticipate user behavior, systems that reorganize around instability, components that understand environmental conditions in real time. This moves front-end architecture closer to resilience engineering, autonomous systems, and infrastructure capable of surviving uncertainty without constant human intervention. Most interfaces today behave like glass. rigid, static, and brittle. The next generation may behave more like biological systems, adaptive, responsive, and anti-fragile. And that changes the philosophy of front-end engineering completely. The future of front-end engineering may not simply be cleaner code, faster frameworks, or better state management. It may be systems capable of adapting faster than humans can debug them. Systems that continuously observe themselves, predict instability, and autonomously reshape their own behavior in real time. Because once interfaces begin responding intelligently to failure, they stop behaving like software and start behaving like organisms.